Thursday, Friday, so you would take out your packets with the assignments that you would turn in for today. So we're going to look at understanding the discriminant and then actually solving the quadratic. So for understanding the discriminant, the answer is in red, and then the work's over there in green. So number 1 was 76, negative 7, 96, 41, 17, and 57.
Wait, what was number 2?
2 was negative 7. And then down at the bottom, we had negative 63. That gave you 2 imaginaries. 0 gives 1 real. 0 gives 1 real. 0 gives 1 real. Negative 224 gives 2 imaginaries. And 0 gives 1 real. So again, in order to be able to do these, you have to make sure the first thing you do is set that equation equal to 0. So all quadratic equations get set equal to 0 to start, except completing the square. 13, you got negative 80, which was 2 imaginary, and 14, 0, 1 real. 15, 121 gave 2, and then we called those rational. If you just said real, that's okay. It's rational because 121 is a perfect square. That also meant that this was factorable. 16 is 0. That made that a perfect square trinomial. Okay, and then we had 17, which was 64. So once again, 2 rational, so that gave you 8 and negative 8 as your square root values. So you would be adding 8 and subtracting 8 from that negative b all over to a. 18, you got 140 for your discriminant. 140 is not a perfect square. Therefore, you got 2 reals, but your answers were irrational. It was also not factorable. Okay, so there's 21 and 22. And then for the critical word problems down in 23 and 24, for these ones, you have a bunch of different answers. So like for 23, it said write a quadratic equation that has 2 imaginary solutions. So if you're writing a quadratic equation that has 2 imaginary solutions, then you needed to... Sorry about that. This computer was muted. There we go. Okay. So if you have 2 imaginary solutions, then what we want to do is make sure that this is not factorable and your discriminant is negative. So you could just play around with a quadratic until you find a discriminant value that is negative. And then in 24, it says, in your own words, explain why a quadratic equation can't have 1 imaginary solution. So the answers for that can vary, but the only reason it cannot be 1 is that if you have 1 solution, your discriminant value is 0, and 0 does not give an imaginary solution. Okay, and then for the next page, I'm going to put up all of the answers. I do have the work too, or if there's any of these you'd like to see, I will gladly do the work for that individual problem for you. So let's start with 1 through 6. Each of those were real rational solutions, no i's, no zeros. They all gave 2 real solutions. Okay, and then in 7 and 8, so I kind of wrote other answers off to the side. If you didn't totally 100% simplify, you may not have what's up there in red. You may have what's in the handwriting. So here you had 4 plus or minus the square root of 592 over 16. But 592 divided by the perfect square 16. So you should have taken out 4. But then that also gave you a 4, a 4, and a 4 that could simplify to the 1 plus or minus the square root of 37. Similarly, in number 8, square root of 124 allowed you to take out that factor, and then you were able to simplify with your GCF of each term. The big thing you want to make sure you have in 8 is an I. The big thing you want to make sure you have is an I. Okay, and then we have 9, 10, 11, 13, and 14. So 9, the square root of 359 does not simplify, so you can't actually take anything out of that. I know it's one I feel like people kind of try. It's such a big number, but 359 does not divide by any perfect squares. Okay. And then we have 15 and 16. Are there any of those you want to see the work for? Anything you don't understand? Sure.
My bad. I just missed 8.
Oh, you just need the answer for 8? Sure. Is everybody okay with the bottom ones? Can I go back to 8? There you go. Okay. All right, so then we are going to pick up with a Jeopardy review. So let me give out my boards to the fronts of each rows. Pull up my PowerPoint.
Sometimes I'm doesn't need that. I can just try to practice Thursday. Yeah, I'll do that. It's still and then I was like, oh, it doesn't feel that bad right now. I wake up tomorrow, I'm like,
You're welcome.
feel my arm.
Alright, so again, I'm behind you, so when you get your answer, you move your board above your head. And that way I can see your answers. So when you have your answer, just hold that board up above your head, and we will check your work. Yeah, honey.
I had a question on number 4, 5, 6 for like a second there. So I didn't know how to get like the fraction answers because for the value under my discriminant, I got 105, and I didn't know if that was the right value under there.
For 4 and 5 on like the handout I just showed you.
I got 5.
Okay, just 4?
Yeah.
Okay. Give me 2 seconds, I'll put that up.
Okay.
You just had to wait till I put it all away, didn't you?
I'm sorry.
It's okay, I'm
I
teasing.
went back to like try and
To like try to do it again.
Yeah.
Okay. So I know I said we were studying our Jeopardy. We're actually going to go back and look at one of the questions from the handout real quick. Then we're going to start Jeopardy because I got a question. So escape that. Back to here, back to there. Stop my share. Turn on my video. All right. Looking at number 4, and it's good anyways. We'll just do a whole quadratic review. We had 2a squared minus a minus 13 equals 2. So the first thing you had to do in that problem was subtract over your 2. So you get 2a squared minus a minus 15 equals 0. And then you find your discriminant, so it's b squared. So negative 1 squared minus 4ac. So 1 negative or positive, anything squared becomes a positive. So you get 1. A negative times a negative gets a positive. And then 15 times 2 is 30. And 30 times 4 is 120. So we get 121 as our discriminant value. So then in the quadratic formula, we now say, okay, negative b, so b is negative 1. So negative b is positive 1, plus or minus the square root of 121, all over 2 times a, which is 2. So that gave 1 plus or minus 11 all over 4. So 1 plus 11 is 12. 1 minus 11 is negative 10. So 12 divided by 4 gave 3. And negative 10 fourths gave negative 5 halves. So that is how I got to those 2 answers. Now again, on your assessment for tomorrow, I'll have basically kind of a way where it says like, okay, you have to do these 2 quadratic formula, you have to do these 2 completing the square, and then there might be like 8 problems, and it'll be like solve these any way you want. So if you had noticed that 2a squared minus a minus 15, even though it's not really a part of the units we're reviewing for, was factorable, way up here, if you had wanted, you could have said, okay, that factors as a minus 3, and it factors as 2a plus 5. So you could have also put it in factored form to get you down to your 2 roots as well. However, if I specify use quadratic formula or I specify completing the square, you want to make sure you use that specific technique for that problem. Are we all okay with completing the square? I feel like it's been a little while since we did that. There will be some on this review handout. So if we start to work through a problem and you're like, I have no idea how to do that, I can definitely do any problem on this area too while we're in our review. Okay, so front row, let's start with the discriminant for 100. That is correct. I think you're also correct. And you're correct, and you're correct. Alright guys, awesome. The value of the discriminant was 36. A 36 gave you 2 real rationals. So first one to get that was my middle row, and Brayden. The first row to get it was the middle row with Brayden. He beat you by like a hair because he was in my light too. Alright. So category and points, Enzo. Anything but the yellow ones. Alright. Factoring for 100. That is correct. It's sometimes the glare gets me. Okay, x minus 3x minus 8. The last term was positive. Therefore, both factors had to be positive or negative. Since the middle term was negative, that meant both terms were Alright, category and points, Lily. Okay, quadratic formula for 100. That is correct. Okay, so -1. Oh, actually, I thought you. That's okay. So what you had to do, ready? In order to make sure we have a full understanding. Maybe. Stop share. All right. So you should have plugged in. I was trying to work it out to show you all the work. You plug in all your values. You got a discriminant of 9. So that meant that you turned this into -1 plus 3 over -2 and -1 minus 3 over -2. So that gave you a -4 over a -2. So that gave you a +2. And then you had a 2 over a -2, which gave you a -1. Yes. No. So as long as but you have to show me if you don't write it down separate. I need to see like the simplified number, because if you would skip this step here, like if you go from this to that, and you get your discriminant wrong, then I don't know like where you went wrong. Okay, category of points go to Spencer. Okay, how many? So this one asks for how many and what type of solutions from that discriminant. So I want to know how many and what type. That is correct. Oh, she beat you. Okay, it is 1 real because the discriminant is 0. It is 1 real because the discriminant is 0. Oh, I didn't think about the your row's a row of 2. Sorry, you two. My room doesn't normally look like this. Okay, category and points go to Brayden. Okay. So for solving equations 100, this is any technique you want to solve. There we go. That is correct. Okay, so you could have picked any technique you wanted. If you subtracted 5, you got 4x squared equals 4. Divided by 4, you got x squared equals 1. So the square root of 1 is plus or minus 1. And Cole did it with quadratic formula, so that worked as well. So again, lots of different ways to solve. But you needed to get plus or minus 1. Is everybody okay with that? Does anybody need to see that written down? Okay, category and points go to Kayla. Okay. So how many and what type? How many and what type? That is correct. All right, so correct answer. The discriminant is negative 116. So you get 2 imaginary. 2 imaginary. Alright. Jacob in the middle row, category endpoints.
Factoring for 500.
Okay.
Let's go.
Oh, God.
Was incorrect. The discriminant term needs to be able to multiply to 3. That is incorrect. That you're so close.
Oh, but you actually have to find the x equals.
Oh, his had. It wasn't even about the equal 0. It was about his signs. Yeah, you needed to flip them. All right, so it looks like we need a little help on factoring. A lot of help. Oh, Quadratic Formula would have been brutal.
Factoring is kind of easy.
So your correct answers, and I just took factored form, but your correct answers were 2 and -4/3. So if you did Quadratic Formula, then you got down to those answers. Now, I had asked for factoring, so if you factored that and factored it correctly, you should have had 3x plus 4, x minus 2, and then this is set equal to 0, so we found our solutions of -4/3 and 2. So I had just said to factor, so if you got the solutions, that's fine as well. Tomorrow, all problems will need to have solutions. However, that is factored form. This would be a case where I would have used a magic X. And again, I knew that 3 was prime though, so that automatically narrowed down my front 2 pieces. I know I needed to have a 3x and an x. Do we need to see anything else involving that? Do we kind of remember how to do it? We're good? All right, so Lily.
I'm good.
No, your category and points. Sorry, dear, didn't mean to scare you there. Okay, quadratic formula for 200. That is incorrect.
Oh, yeah.
That is correct. Yeah, you had your discriminant. That's honestly why I was so confused. I was like staring at Nick's work going like, he has the discriminant as 0, but now all of a sudden he's adding 1. I was like, ah. Alright, so your discriminant was 0. The minute your discriminant is 0, it means you only have one solution. And that solution was 1. You're fine. You're fine. Okay, let's go.
Complex numbers for 500.
I like it. I like it. Everybody ready?
No. I'm losing.
Simplify I to the 728. Did you just pick a random
No,
one, or
I
do you
know
know that
it.
it was? Okay, that is correct.
Easy.
So he knew that 728 divided by 4. If the exponent divides by 4, then it means that the value of the I is automatically 1. Because there is no remainder, therefore 1.
As soon as I saw 28.
Well, 72 divides by 4 and 8 divides by 4, so you know that 728 divides by 4.
I struggled in division in 3rd grade.
I struggled with it. All right, Miss Tessa, category of points. Okay, factoring 200. Solve. I'm scared that there's nothing. No, that's factored form. I want solutions. I want this. What are the solutions? Solve that equation. That is correct. Guys, don't overthink it. If two factored forms are set equal to 0, the solutions are each of those factors set equal to 0. Hence, 10 and negative 6.
Oh, Lord.
Category of points, Jacob in the middle again.
Solving equations for 500.
All right. You picked it.
I'm so sorry.
For 1970 through 1999, the population of Madagascar is modeled by the following function. During which year was the population going to equal that? So, think about how you find when a population equals a number. This is a completing the square. This is a completing the square. You can do this, I guess you could do it as quadratic formula too, but man, your numbers are going to be gruesome. Man, quadratic formula is not terrible, actually. So again, if you do completing the square, you'd have to subtract the 6,750 over and divide by 6.4. If you do a quadratic formula, you have to take 6,750 and subtract 8,740,000 and then plug in to quadratic formula.
Whoa. And it's like the barometer on
So just pick a random year.
Yeah.
I'm gonna say 78. It's probably not. I'll say 78.
Okay, do we want to see the work for this?
Yes.
Okay. Do you want to see it as quadratic formula or completing the square? Alright. So I heard quadratic formula, that's fine. So you take your 6.4t squared plus 135t plus 6750, and you want to know when that equals 8,740,000. So then what you would do for quadratic formula is subtract that away, because you cannot have quadratic formula equal to a number. So you get 6.4t squared plus 135t, and then 6750 minus 874,000 zeros. I have an extra one. And you get minus 8733250 equals 0. So now you just plug into quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c, because you have a calculator, so I don't know why, times 2a. So then at this point, you just go on your calculator, and you would take 135 squared minus, put in parentheses, 4 times a times, make sure you get the negative for the c, and then it's 8733250, and hit enter. And again, take your calculator, hit second square root, then you can hit second answer, so you don't even have to type that back in. And then you get that 14,952. So it's negative 135 plus or minus 14,952.907 divided by, and if you want, you could take 2 times 6.4. And again, if you're concerned about your own math, type it on your calculator. But that's 12.8, because 64 times 2 is 128. So 6.4 times 2 is 12.8. Now, think about the fact that if you do a negative and a negative, your answer is going to be negative. Can we have a negative here? No. So we're only going to take into account the positive answer. So again, on your calculator, you could highlight that answer, and then you could subtract your 135 from it. and then divide it by your 12.8. And you get 1157. So that represents that population. To find your year, you would have to plug it in.
This number is about to be humongous.
So 1980 was your actual. All right, so our bell's going to ring here in a minute. For tomorrow, make sure you need to know a few things. You want to make sure you know your powers of I. So you need to know I is the square root of -1. I squared is -1. I cubed is -I. And I to the 4 is 1. You can never have an I in your denominator. If you get an I in your denominator, you have to rationalize. So that's where you multiply by your complex conjugate. So it's been a while since we looked at the complex, and we didn't really do any of that complex column. So I will post that Jeopardy board later today in Teams, so you can kind of click through if you want and look at the complex. Yes, Jake. That detailed, no. Actually, I don't even know if I was mean enough to give you a word problem on this quiz.
Complex numbers are like Jamie.
Yeah, I have like an explanation, but not a
Okay, I can explain things.
Never mind, Jamie.
Don't say the word vocab on the quiz.
Yes. Guys, there is like an area where you have to know and understand your vocab though. Because
I'm gonna make a study guide.
probably like 100. Because I have like a combination of like 4 of them I picked my problems from.
It's actually right. After you, my good